Okay, so in the third portion of this video series, we're going to be talking about the constant multiple rule. So this is going to infuse the power rule, but also have this constant in front. And what the rule says is if f is a differentiable function and c is some real number, then if you have the product of c and the function and it is differentiable, then the derivative will be that constant times the derivative itself. So that's a little bit confusing, but here's how I approach it. These all are examples of things that will involve the constant multiple rule. So in number 14, y equals 2 over x. So I'm going to write this in the following way. This is the same as 2x to the negative 1. Again, from the previous slide, we want our x to be in the numerator with a clearly identifiable exponent. So we're set up for that. So our constant in this case is 2. What you could do in the beginning, and I'm sure you'll probably end up adjusting for it, but just ignore the 2 for a moment. So if we were to find the derivative right now, we would have that negative 1 leap down in front. We would write the base x, and we would decrease the negative 1, making it negative 2. However, this 2 here that we ignored temporarily, we're going to put it back in. So that 2 that I ignored, I put back in. So the final answer is going to be negative 2x to the negative 2. But of course, we need to correct for the negative exponent, so this is going to end up being negative 2 over x squared. So lots of manipulation here to get to the final answer. It's a bit nuanced, and some kids feel like they can't be bothered by these little actions we're taking, but it's all best practices. So really try to get in the habit in the beginning of doing this. Let's try another one. You'll get better and more proficient at this as we go on. So this one, I feel like the constant is not clearly identifiable like it was in the first one. This 2 just jumped right out at us. So what I'm going to do is rename this as 4/5 t squared. I just feel like that looks a little bit better. So our constant is 4/5. I'm going to just ignore it for a moment. And my notation is going to be f prime of t equals, I'm ignoring the 4/5, I'm just dealing with this derivative. So the 2 leaps in front, I leave some space, I write the 2. This drops by 1 to a 1. But now I want to put this multiple back in of 4/5. Putting it all back together, I end up with a final answer of 8 over 5t. Okay. Number 16. Y equals 2 root x. So this is blending some elements from the page before. So I'm going to rewrite this as 2x to the 1/2. We've got this constant of 2. I'll deal with that at the end. I'll block it with my finger. So this is going to be y prime. The 1/2 jumps in front. I rewrite the base, x. I decrease 1/2 by 1 to negative 1/2. But now I also don't want to forget about this 2, so I'll put it back in. There it is. So 1/2 of 2 ends up being just 1. So I'm really left with just x to the negative 1/2. But I need to correct for the negative exponent. So this is 1 over x to the 1/2. So lots of shifting, lots of algebraic maneuvering. Okay, number 17. This is going to be the same as 1 over 2x to the 2/3. Converting from radical to fractional exponent. But the variable x really ought to be on top. So this is going to be 1/2 times x to the negative 2/3. Here's my constant 1/2. I'll deal with that at the end. So y prime, let me block it like I've done. y prime is going to be negative 2/3, leave some space, write the base, decrease negative 2/3 by 1. Decreasing by 1 is like, in this case, decreasing by 3/3. So negative 2/3 minus 3/3 is negative 5/3. But we have to put this 1/2 back in, which we'll do right now. Now we have an opportunity to cross cancel. The 2's cancel out. So now we have negative 1/3 x to the negative 5/3, which is really negative 1 over 3x to the 5/3. So lots of maneuvering. All right, almost done here. Number 18. So what I'm going to do with this one, I'm just going to make that constant in front really clear. Negative 3/2 x. Well, this brings us back to the very first video in this series. This is just a line, and the derivative of a sloped line is really just the slope itself. So the derivative is going to be just the slope itself. Done. Number 19. Let's see what we have here. I feel like this x needs to be on the top, so this will become 7/3 x squared. Here's my 7/3. I'm going to block it off. So y prime is going to equal 2. Leave some space, write the base. The power of 2 drops by 1 to a 1. Put the 7/3 back in. And now we have 14/3 x. And finally, we have 7 over 3x all to the negative 2. So this 19 and 20 look really similar. Again, it's nuanced in its difference. They look really very similar, but if you look closely, the parentheses kind of change everything. So I'm going to move this chunk that is to a negative exponent up. So this is 7 times 3x squared, which is 7 times 9x squared, because if you square this, it becomes 9, and if you square this, it's x squared. So this is really 63x squared. 63 is your constant. Let me block it. So y prime is going to be 2. Leave some space, write the base. The power of 2 drops to a 1. Let us not forget about that 63. And the answer ends up being 126x. So here were a few cases of something known as the constant multiple rule.